Slope-intercept form of a line. So this is a form of a line that's going to be very helpful, especially in graphing, and so therefore we write a lot of our lines in this form. We also write it in this form because this is in the form of a function also, since it's the y equals, or we could have f of x equals. In slope-intercept form, it's called slope-intercept because m, as we learned before, represents the slope, and then b represents the y-intercept, not the x-intercept, but the y-intercept. So that's very, very crucial. M is the slope of the line, and b is the y-intercept, and the y-intercept is where the graph crosses the y-axis. And so all lines except vertical lines can be written in this form, and it's useful because it's very easy to graph from this form. So what we're going to do, we are going to eventually graph from this form, but first of all, what we're going to do is we need to be able to take any linear equation like this 7x plus 2y equals 14 and put it into slope-intercept form. Now when you see something like this, that's really the same as solving for y. So when you put it in slope-intercept form, you're going to solve for y, and we want to get it in this form where y is equal to something times x plus b. So we'll take the 7x plus 2y equals 14, and we're going to solve for y. So we know that we're supposed to subtract 7x from both sides, and what we get there is 2y equals, and I'm going to put this term with x in it first because that's what happens here, so negative 7x and then plus the 14. And then we're going to divide each term by 2. So we're dividing both sides by 2. Dividing both sides by 2 is really the same as dividing each term by 2. And we end up with y equals, and I'll leave it as negative 7/2 because you could write negative 3.5, but when we're graphing something, it's nice to have it as an improper or as a fraction so we can do our rise over run. And so negative 7/2 x plus 7. And that's in slope-intercept form. From that, it didn't ask for this, but you know that the slope is negative 7/2, which when you have something like this, remember this, it's a negative 7/2. That means the negative can go either with the numerator or it could go with the denominator, because a negative divided by a positive is negative 7/2, or a positive divided by a negative. So our slope is negative 7/2, and our y-intercept, where the graph crosses the y-axis, is the point 0, 7. It's a point, so the y-intercept is a point, and so we can write it as a point. We could say the y-intercept is 7, but here we put the point 0, 7. So here's how we use slope-intercept form to graph a linear equation. We go ahead, if necessary, write it in slope-intercept form. Sometimes it's in that form already, sometimes it's not. We would have to change it kind of like we did the last example. What we do then is we plot the y-intercept, which is 0b. It's this number here. Remember, that's our y-intercept, so we put that on the y-axis. And then from there, we're going to use a slope to get some different points, and then draw the line through those points. So here we have y equals 2/3 x minus 2. And so what we do, it's already in slope-intercept form. Our y-intercept is this negative 2, so we're going to put a point here at negative 2 on the y-axis. So that's our y-intercept, negative 2 on the y-axis. And our slope is 2/3. That means we have our rise is 2 to our run 3. So what we can do is from this point, we go up 1, 2, and then over 1, 2, 3. And we put a point. And we can keep doing that. Now from this point we go up 1, 2, 1, 2, 3. We get that. Now another thing about this is equal to negative 2 over negative 3, because a negative divided by a negative is positive. So really we could also from this point go down 2 and left 3 and get a few more points on our graph. And so there's several points, more than what we need, and we can draw our line through those points, and there is the graph of y equals 2/3 x minus 2. Our next example here, write 4x minus 5y equals 15 in slope-intercept form and then graph it. So what we're going to do here is we're going to take our 4x minus 5y equals 15. We're going to put it in slope-intercept form, which that means we're going to solve for y. So we'll subtract 4x from both sides. And this is negative 5y equals negative 4x. Remember, we like to put that x term first, and plus 15. And then we'll divide each term by negative 5. And simplify, we get y. This is a negative divided by a negative, so this is a positive 4/5 x. And then 15 divided by negative 3 is negative 5 is negative 3, so we could put plus negative 3, or we could have just put minus 3. Either way is fine. So we have it in slope-intercept form. You might again see it like this: y equals 4/5 x minus 3. And either one of these, we can use this to graph. This is our y-intercept. It's where it crosses the y-axis. So we start there at negative 3 on the y-axis. We can use our slope of 4/5. So we can go up 1, 2, 3, and 4, and then over 5, 1, 2, 3, 4, and 5. We also can go down 4, 1, 2, 3, 4, and left 5. And again, that's because negative 4 over negative 5, it's a negative divided by a negative, is still equal to 4/5. And then we can put our graph through those points, and that's the graph of that line. Next example here, write y equals negative 2 in slope-intercept form. State the slope and the y-intercept and graph the equation of the line. Well, we know that slope-intercept form is y equals mx plus b. Now, y equals negative 2 does not have an x term. Well, not having an x term means there's 0 x's. So if we wanted to put this in this form, we could put y equals 0x, and then this is a constant, so we could put a minus 2. And again, we do that because there's no x term, so we put 0 x's, and then this is our constant, so we put that minus 2. That ends up being our b, and this is our slope. So it says state the slope. Well, the slope is 0. The y-intercept is, it's a point, remember, so it's 0, and then remember this is our y-intercept, so 0, negative 2. And then graph the equation. So what we're going to do, we're going to start here with our y-intercept that's at negative 2. It has a slope of 0. Well, we can think of this two ways. The first way is we can think of the slope, and 0, like sometimes it's helpful to think of slope as a fraction, so 0 over really any number is 0. So we can just put 2 in here if we wanted. You could put 1 or 3 or 9, whatever, which means we go up or down 0 and right 2. We go vertically 0 and then right 2, and we see that we have a horizontal line, which brings us to the other way we could have graphed this. We know that a slope of 0, we talked about slope recently, slope of 0 means it's a horizontal line, so we could have known it there, and we could have known, okay, it has a slope, y-intercept of negative 2, the slope is 0, and so it's a horizontal line. And actually, we also learned that anything in y equals a constant form is a horizontal line. So there it is, slope-intercept form, the slope, the y-intercept, and the graph. This last one here is an application of what you can do with linear equations. And so there's this online company that makes photo albums that you can upload with your photo files. Sarah pays a $25 membership fee and gets a good price on her photo album, which is going to be $1.25 per page and free shipping. So you can pay a membership fee up front, and then you can get these photo albums for $1.25 per page. Write a linear function rule for the cost and graph the function. Then determine how much it would cost Sarah for a membership and a 23-page photo album. So we want to write an equation for cost. So let's let C equal our cost and N equal the number of pages. We've talked about stuff like this before, and so we want an equation for our cost. So we can put cost equals, and then we think through what our cost is. Well, no matter what, if you get a membership fee, it's $25. So we know it's going to be $25. So if she pays the membership fee and never buys a photo album, it's $25. If she buys an album, how much the album costs depends on how many pages there are. So it's determined by how many pages. And if there's one page, you pay $1.25. If there's 2 pages, you pay $1.25 times 2, which would be $2.50. And so what we can see there is you take your number of pages, N stands for the number of pages, multiply it by $1.25, and that's how much you would pay for that album for N number of pages. So if we put 10 in here, we could figure out how much it would cost for the membership in 10 pages. I'm going to go ahead and rewrite this a little bit differently so it looks like a linear equation, because linear equations are in y equals mx plus b form, where this is a number, that's our slope, and this a number will go in our y-intercept. Well, we can write this equation down there kind of like that. We don't have a y and an x, we have a c and an n. So I'm going to put the n term first, just like we usually have the x term first, and then I'll put the constant. And so here's what the equation will look like. The cost is $1.25 times the number of pages times n plus $25, which is that fee, the membership fee. And then, so that's part of the answer. Sarah, how much would it cost Sarah for a membership and 23-page photo album? Well, what we can do is we can put 23 in for n, and put that into our equation, and that will help us figure out how much this is going to be equal. So we'll do 1.25 times 23, and we get 1875. So we get 1875, if I did my multiplication correctly. 1875 plus 25, that will give us a total of 43.75. So with the membership fee and a 23-page album, as long as I did my math right, you get, it's $43.75. And that's linear equations. A very, very important part of that is knowing your slope-intercept form of a line, which is y equals mx plus b, where m stands for the slope, b stands for the y-intercept, which is where the graph crosses the y-axis, and being able to write equations in this form and then use this form to graph lines is crucial.